Okay, let's get started here. So said we'll pick up with, here, question number 10. All right, and please, as we go along, if you either have questions or, if I ask a question about the question that we're on, something maybe what reminds you of this, or what would be a relevant formula here, or what idea are we talking about here? Post it in the chat. That way I know you're with me. We're all on the same page here as we go along. Okay, number 10. We have this equation, ax cubed plus bx squared plus cx plus d is equal to 0. In the equation above, a, b, c, and d are constants. The equation has roots -1, -3, and 5. Which of the following is a factor of ax cubed plus bx squared plus cx plus d? So this is a complex, polynomial equation we have here, right? Ax cubed plus bx squared plus cx plus d. It's all equal to 0, though. And that's important. So we're talking about a factor. So what can we pull out of this that would be equal to 0? Right? We want like a nice little factor, a little section of this overall polynomial that would be equal to 0. So this is our hint here. They tell us that we have roots -1, -3, and 5. Those are our answers, right? Those are numbers that if we plug in, this polynomial should equal to 0. So if we look at how these numbers, -1, -3, and 5 align with our answer choices, what factor could we pull out from this polynomial that's equal to 0 and solve it with a -1, -3, or 5? Well, if we look here, the answer to this factor, x minus 1, would be 1. So that's not one of our answers. So no, can't be A. If we look at B, we have this factor x plus 1, right? If that x plus 1 is equal to 0, what would solve for that would be -1 for x. So we're saying our x here would be equal to -1, and that works because that's one of our roots. Let's just look at the other answer choices and see what these mean here. So B looks like it's the right answer. C, x minus 3. So once again, we're saying that x minus 3 should be equal to 0 if it's true that it's a factor. To solve for that, we know that the answer for x must be 3. We have -3. -3 and 3 are not the same thing. So no, C doesn't work. And if we're looking here at D, x plus 5 is equal to 0. Right, we know that what must solve there for x is that x must be equal to -5. Once again, we have 5 as a root, not -5, so that one doesn't work either. B is our answer. Okay, number 11. Might have done, this one looks kind of familiar, maybe the one that we did last week about fractional exponents and variables there and simplifying. But anyway, even if we did do it, it's good review. So let's go through it. So we have the expression x to the -2, y to the 1/2, the product of those two in the numerator, over x to the 1/3 times y to the -1, where x is greater than 1 and y is greater than 1, is equivalent to which of the following? So if we look at all these answer choices, right, they still look kind of complex, and we see radicals being introduced where there's no radicals in the question that we're given. But we know that we want to simplify this somehow. So let's write what we get. We have x to the -2 times y to the 1/2 over x to the 1/3 times y to the -1. So let's just start out with looking at one variable. I'll take my x term first and try and simplify that. So if I have x to the -2 up top and x to the 1/3, if we remember when we divide, which we're going to have to here because one of my x terms is in my numerator, the other is in my denominator. When we divide, we subtract the exponents. And we just have to be careful in terms of which way we're subtracting. And when I say that, in which way we're subtracting, I mean, if I'm going to take my numerator term and then subtract my denominator term, I need to place my answer in the numerator. If I was going to do the opposite, which is a little bit more confusing, I would put it in the denominator. Anyway, if we have x to the negative second up top divided by x to the 1/3, what I'm really doing is subtracting these exponents. So I have -2 minus 1/3, and I need an answer for that. What that answer will be the exponent on my x term now. So I want to put this -2, in terms of thirds. That would be -6/3. Subtracting a third would give me -7/3. So now simplifying this, I have x to the -7/3, and hopefully that's kind of standing out to you as something being wrong with that, and we'll go from there. So that simplifies my x terms. Now, if I look here at my y terms, I have y to the 1/2 over y to the -1st. In this case, 1/2 minus a -1, right? Subtracting a negative means I'm really adding. So I'm adding 1/2 plus 1. 1/2 in terms of twos is just 2 over 2, right? So my answer there is 3/2. So I have x to the -7/3 times y to the 3/2. That's true. My math is all correct there, but I want to simplify that a little more. Like I said, none of these answer choices over here have that answer. So this tells me I need to work with what I have so far a little bit further. So x to the -7/3, let me write this down here, times y to the 3/2. And I'm going to rewrite this. So let's look at that x term first. Ideally, you shouldn't have a negative exponent. That means that your fraction is really unsimplified, or it's written in a way that's not usually accepted as being correct. So to undo that, or to switch the negative sign, we can flip this x term down to the denominator. So I can keep my y term up top, y to the 3/2. Flip this x term down to the denominator. I have x to the 7/3 now, right? Same value, it's just opposite in sign. Okay. So now this is a little bit better to work with. Let's look at this y term. So once again, we talked about this last week. If we have fractional exponents, that 3 in the 3/2 here, the exponent on y, means that's how many copies of y we have. So if we have 3, we're really cubing it, whereas if we had 2, we'd be squaring it, right? So if we have 3, we have this y cubed term. That 2, the denominator of our fractional exponent, tells us that we're taking the square root of y. So that's a rewritten form of y to the 3/2. I'll leave that there for now. Let's go down here to this x term. Same thing, this one's a little bit more complex, right? 7/3 is a stranger and larger fraction than 3/2. This tells us that we have 7 copies of x, right? We have x to the 7th. And that 3 in the denominator tells us that we're taking the cubic root, or the third root of this term. Okay. So let's look once again back up top. I've rewritten these two fractional exponents into better, a little bit more understandable forms of how we can use them. So if I look up here, if I'm taking the square root of y cubed, I can't take a perfectly even square root of y cubed, right? There's no simple way. It would be like y to the 1.5, but I can't do that. So I want to split this into something I could take the square root of, which is y squared, and the remainder of that will be y to the 1st. I can take the square root of y squared, it would just be y. And what would be left would be y to the first under the radical. So y to the square root of y is how my numerator solves. Okay, and if I look down here at my denominator, now I want to think about really how many times can I fit 3 into that x to the 7th? I can't take the cubic root of x to the 7th straight up. It doesn't work. So what I need to do is same thing that I did with my y term, separate this x to the 7th into factors really that we could take the cubic root of. So x to the 3rd would be 1, x to the 3rd would be another, right? That accounts for 6 of my 7 copies. And then x to the 1st will be my last, right? 3 plus 3 plus 1 gives me that 7, the x to the 7th that I started with. And we're taking the cubic root of all these. So the cubic root of x to the 3rd would give me x. That would simplify this term right here as x. The cubic root of this next term, again, would be x. So I'll have x times x. And then the last one, I can't take the cubic root of x to the 1st, so I have to leave that there. What does simplify outside of my radical, though, is this x times x. So that's x squared. What's left of my radical is the square root of x. So I have x squared times the square root of x in my denominator. That is my answer. So what we got, once again, that should be the 3rd root. This looks like answer D. It's a complex problem, right? It takes a lot there. We got to subtract exponents and rewrite things and simplify things and make this shift from describing these fractional exponents just as numbers now to more practical applications of them in a radical. All right, so that was number 11. Let's look here at number 12. It says the function f is defined by f of x equal to the product of x plus 3 and x plus 1. The graph of f in the xy plane is a parabola. Which of the following intervals contains the x coordinate of the vertex of the graph of f? So let's think about this. We know we have a parabola. We don't know necessarily if our parabola might line up perfectly with y-axis, right? It will be perfectly symmetrical. Let's say it does, but it's not exactly relevant to the question. But we know that this vertex that they're talking about, that the vertex of the graph, is like the bottom half of if our parabola kind of looks like a U shape, right? It's the bottom of that parabola. And we know the vertex kind of, let's say if my parabola looks like this, my vertex is here, right? That's like this nice line of symmetry where I could fold my parabola in half, it would meet perfectly right at the vertex. Anyway, what are we looking at here? The vertex of the parabola and the midpoint of the segment between the two x-intercepts of the graph have the same x-coordinate. So if I look at my values here, right? If I see that if I plug in a -3 for x here, right? That makes this term go to 0. So that means if I plug in a -3, my y term must be 0. So that must be 1 point on my parabola, on my graph here. And then with this x plus 1, if I plug in a -1, once again, my y value will be 0. So about here. And I know that both of these points should be right on the opposite side of my parabola. My parabola must be something like this, right? And clearly I can see that my vertex right here must be between this 0, -3, 0. Get my coordinates backwards. -3, 0, and -1, 0. Those two coordinates, right? The question says, Which of the following intervals contains the x-coordinate of the vertex of the graph? We don't need the actual full coordinate. We don't need the y value too, just the x-coordinate. So it must be between -3 and -1. So if it must be between -3 and -1, let's think about some here that don't make sense. Not this, right? -3 and -4 would be somewhere over here. B, -3. Let's come back to B. Let's look at C. Between 1 and 3, well, that would be over here, right? That's definitely not in our range. And D, between 3 and 4, that's even further away. That's over here, definitely not. Now, if I look at B, between -3 and 1, well, we said more specifically it should be between -3 and -1, but this range has that -1 within it. It's just a slightly broader range. It's a little bit larger than we'd need, but it still includes our answer, right? It would be some range around here. And once again, we're just talking about the x-coordinate of that vertex, so B is our answer. Let's look here at 14. A shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. So let's think about that. Sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. Cannot exceed 130 inches. So we know we're talking about like some topping out or capping at 130 inches. So it could be represented by some inequality like that, right? It needs to be less than or equal to 130 inches. Can't go above it. The perimeter of the base is determined using the width and length of the box. If a box has a height of 60 inches and its length is 2.5 times the width, which inequality shows the allowable width, x in inches of the box? So this x here is talking about our width in inches of the box. Let's see. So let's try and make some statements out of what we're given here. So the box has a height of 60 inches. So let's say h is equal to 60, okay? And its length is 2.5 times the width. We're calling this width x here. So length, we'll say, is equal to 2.5 times the width, which is x. So L will be equal to 2.5 x. So if we think about this, we have this box here. Let me try and draw a little three-dimensional. Right, so they tell us our height here is 60. I'm going to call this height here, but we know that goes around because we're talking about a rectangular prism. That height should be 60. And let's see here. I'm going to call I'll call this my width, so that's x. This back width here, that'll also be x. And then we'll call this side the length, which would also be this side too. And that length is 2.5x. And that length over here is 2.5x. So the question tells us that the perimeter of the base is determined using the width and length of the box. In the previous sentence, they say the sum of the perimeter of the base of the box and the height of the box. So the perimeter of the base plus the height cannot be over 130 inches. So what's the perimeter here of this really this square here at the bottom that's making up the base of our rectangular prism? Well, we just need to add the sides up together, right? We know it's 2 times the length plus 2 times the width, or you can just add them all straight across. So my perimeter here my perimeter here should be equal to 2.5x plus 2.5x plus x plus x. 2.5 plus 2.5 gives me 5 plus another x plus a 1x plus 1x. My perimeter here must be 7x. And then they tell me that my height, right, we knew was equal to 60. So let's throw this all together here. I know that my perimeter of 7x plus my height of 60 cannot exceed 130. Must be less than or equal to 130. So then I can subtract 60, right? I want to put this in a more simplified form. We can see that this inequality that I have here, it's not very simplified. We could write this in a better way. So if I subtract 60, I get 7x is less than or equal to 70. Divide by 7, divide by 7. I get, oops, just happened. Sorry, hang tight for a sec. Let me just rewrite what I had. I don't know what happened there. Sorry about that. We had 7x plus 60, I'll start here, was less than or equal to 130, right? Can't exceed that 130. I subtract 60, 7x is equal to, I'm sorry, it's less than or equal to 70, divide by 7, divide by 7. My inequality solves as x is being less than or equal to 10. Let's look at my answer choices here. I can see A immediately gives me the same inequality, just kind of bottoms out here at 0, which makes sense. It should be greater than 0. It can't be greater than or equal to 0 because we can't have a rectangular prism with a width of 0. So A makes sense. That's my answer. All right. Let's look here at 15. So the expression 1/3 times x squared minus 2 can be rewritten as 1/3 times the product of x minus k, excuse me, and x plus k, where k is a positive constant. What is the value of k? So we're looking for this value, this constant k, and we know clearly k is taking, the k here has some relationship to this minus 2 term, right? It needs to either be like factored in some sense, rewritten. We know we're getting this k from some operation being done on that -2, that x squared minus 2. Okay. Well, we have to pay attention to think about how this is written, right? We see that they're rewriting this as 1/3 times x minus k times x plus k. They must have divided this entire thing. They must have divided our entire equation to begin with by 1/3. So they're not just pulling the 1/3 off that x squared term, which makes sense. They're also pulling out a 1/3 from -2. So we have to think about that. We have to factor that in here, right? Because if I divide my x squared term here, let me rewrite this. If I divide my x squared term here by 1/3, right? I can now pull that out. It's off my x squared term. I also need to do it here. If I divide my -2 by a 1/3, right, now I can pull this out. I have a 1/3 out here. I know clearly my x squared term will just be written like that. But when I divide -2 by a 1/3, remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So -2 divided by 1/3 means multiply by its reciprocal, which is 3/1, really just 3. So I get -6. So if I was going to rewrite this, this is really x squared minus 6. All right, if I didn't, let's say if I didn't treat that 2 term with respect to this 1/3, I would get a different answer here. If I left it as 2, my answer will almost definitely end up being wrong. So now let's look here. It says where k is a positive constant. What is the value of k? We know that this must be a difference of 2 squares. That's not really so important. We're just looking really at this relationship between k and this, now this -6 term here, right? If I look here, my difference of 2 squares, the relationship between these k terms and this 6 would be, if I multiply them by each other, right, a -k plus a k, -k times a positive k would just give me another -k squared. -k squared must be equal to my -6. I'm just simplifying here. Now k squared is equal to 6. Take the square root of both sides. K, my constant, is equal to the square root of 6. That is answer D. It's an important part there is just to remember that when you factor that whole thing, it would be easy to just kind of pull it off the x squared term, but we have to take it from both. Okay, moving into the grid-in. I think they call these like the grid-in type problems. We got 16, 17, 18. Yeah, we got about 5 questions here. Let's finish this up. Number 16, this one's pretty straightforward. It says if 2x plus 8 is equal to 16, what is the value of x plus 4? So given that equation over there on the left, we need to just solve for x. We can take that value of x, plugging in x plus 4, and get our answer. So to solve for x, I need to subtract 8, 2x is equal to 8, and I need to divide by 2, x is equal to 8 divided by 2, my x value is equal to 4, plug that in over here, 4 plus 4 is equal to 8, that's my answer. I'd grid in 8 as my answer. All right, number 17, got a little geometry type problem. Okay, an interesting looking shape here. In the figure above, segment MQ and segment NR, MQ here and NR here, intersect at the point P. NP is equal to QP, and MP is equal to PR. What is the measure in degrees of angle QMR? So ultimately, we're looking for this angle, what we got here, QMR, right? We want this angle here. We're looking for that angle. So given the true statements in the problem, we can analyze this figure a little bit more and see what angles we must know based off what we're given. I can see right off the bat here that this triangle PQR here, right? I have 2 out of the 3 angles. I know they must add up to 180, right? 60 plus 70 plus whatever this angle QRP is, call it X, must be equal to 180. It's 130, oops, 130 plus X is equal to 180. I know that X, this angle QRP in the bottom right, must be equal to 50. That's not the answer that we're looking for, but just one piece of data that might be helpful to know later down the line. Okay. Let's think about the angle that we're looking for, where it is, and how we might be able to, say, head in that direction. Okay. We are looking for angle QMR. Once again, that's this angle here in our bottom right. So they tell us that lines NP and QP are equal. So Draw a line there, line there. And they also tell us that line MP and PR are equal. So throw a line in there, so 2 lines to make sure I'm specifying these 2 different sets of segments that are equal to each other. What can I do with that now? Well, if I think about it, I think it's more obvious here for this triangle MPR. I can see that that's a triangle, and if I have 2 legs that are equal to each other, I must have an isosceles triangle. That also would apply for this, let's say this hypothetical triangle here. If I just drew in this imaginary line here, I also now have an isosceles triangle in NPQ. If I know the lengths of 2 sides, I know that 2 angles, 2 sets of angles in that isosceles triangle must be equal to each other. So what jumps out to me right off the bat is that this straight line here, right, must be equal to, the angle of the straight line is 180 degrees. So if this angle QPR is 60, this angle MPR must be 120. Okay, that's helpful. So I know also this vertical angle NPM must be equal to 60. This angle P up here, and be more specific, NPQ must be equal to 120. I know that, here, I know that this isosceles triangle MPR, right, drew these 2 legs here, being equal to each other, so that this angle and this angle must be equal to each other, and that includes angle QMR, which is helpful. So I know that 120 plus, I'm going to call each of those angles X and X, plus 2X must be equal to 180. If I subtract 120, try to fit this in here, let me bring it over here. 120 plus 2X is equal to 180. Subtract the 120, subtract 120, 2X is equal to 60, divided by 2, divided by 2, X is equal to 30. That's the angle here that we're looking for, 30 degrees right here. Also applies to that angle, 30 degrees. Let's just check. You're looking for angle QMR, right? They tell us angle QMR here, and yep, that fits. That's that angle right there. So that piece of information that you know, those sets of legs that were equal, that's our jumping off point. Okay, they're equal. Well, there's an isosceles triangle. Those angles must be equal to each other. And then given a couple sets of degrees here, right, we can make some inferences about what must be true about the other angles and other segments of this figure here. All right, that was number 17. Moving on to 18 here. It says the number of radians in a 720 degree angle can be written as A times pi, where A is a constant. What is the value of A? Well, radians are another stranger unit really of degrees. And if you've taken trig or pre-calc, especially when you talk about the unit circle, right? The unit circle is described more often in terms of radians, right? We know the whole volume of the whole measure of angles in a circle are 360 degrees. In terms of radians, that's 2 pi. So we know that 2 pi, is equal to 360 . Oh yeah. So there are pi radians, right? It's a weird unit to think of degrees, and we think of pi as having this relationship with circles, and it does, but we can say that pi radians, call it pi radians, are equal to 180 degrees. So the question is, if 1 pi radian is 180 degrees, how many of those pi radians do I need to get to 720? Well, I can see, right, if I multiply 180 by 4, I need to multiply this by 4. If I multiply 180 by 4, I get to 720. So I must need 4 pi right? Another way of doing that would just be dividing 720 by 180. This is a non-calculator section, but hopefully you can see that those work, right? This is really just 72 divided by 18. It's the same thing. It will be equal to 4. So that means that there's 4 pi radians in 720. So the value of A, though, is all they're asking. A is equal to 4. Strange unit of degrees, but definitely one that we need to know. Like I said, usually applies in terms of unit circles, but that's a good fair question there. That was 18. We're on our last 2 here in this section. Yep. All right, let's look at 19. The graph of a line in the xy plane passes through the point 1, 4 and crosses the x-axis at the point 2, 0. The line crosses the y-axis at the point 0, b. So that's our y-intercept here, right? The question is, what is the value of b? So they're really asking, what is our y-intercept? What is the value of y for our y-intercept? The graph of a line in the xy plane passes through the point, so let's call it this point 1, 4. We have another point here, 2, 0. It's x1, y1, and x2, y2. Here it's 19. Right. x1, y1, and x2, y2. Well, if I want to represent, I need an equation of the line, right? And if I write an equation of the line, then I can try and find out what this b value is. But to do that, I need the slope. So I need to find m, a variable for slope. And I know that that formula is y2 minus y1 over x2 minus x1. If I plug these in, my y2 here, I define as being 0, minus my y1, I define as being 4, over x2, I define as being 2, minus my x1, I define as being 1. Simplify that. 0 minus 4 up top will give me negative 4. The bottom, 2 minus 1, will just give me 1. So my slope here is negative 4. Okay, that's helpful. And now if I want to simplify, I'm going to write my equation of the line. I know y is equal to mx plus b. We're really solving for b, right? We're solving for the y-intercept. I have my m. I just found that. And I can plug in a y value and an x value, just given one of those points, right? Either of these points here, 1, 4 or 2, 0, must satisfy that equation in order to be represented by that equation of a line. So I have y, I have m, I have x, I can solve for b, which is what I'm looking for. So I plug everything in and then solve for b, and I should be done. So my value for m, once again, was negative 4. It's right here. And I'm going to use the point, doesn't matter which one you use. I'm going to use this point here, 2, 0, because I like that 0. It'll knock out one of my variables right off the bat. So maybe some simpler numbers to work with too. So I'm going to plug in this point, 2, 0. My slope, m, is negative 4. So let me put all this in. So my y value is 0. So 0 is equal to m. My slope, negative 4 times x, which is 2, plus b. 0 is equal to negative 8 plus b. Add 8 over. Add 8 over. B is equal to 8. That's my answer. That's my y-intercept. So if I was going to write my full equation of the line, y is equal to mx plus b, I know my slope is negative 4. X and m plus 8 would be my line. All they're asking for, though, is the b. And that's right here. B is equal to 8. So I would grid in 8 as my answer. I think that was 19. So we're on to 20. This is our last question here, number 20. All right. So we have this equation in parentheses, 7,532 plus 100y squared plus 10 times, in parentheses, 10y squared minus 110. The expression above can be written in the form ay squared plus b, where a and b are constants. What is the value of a plus b? So we're looking for this value of a plus b, so we need to find a and b both as constants, and our answer is just going to be the sum of these two constants. So what I see here, right, I have my y squared term introduced once over here and then another time over here. It's embedded within these parentheses. It's also embedded within these parentheses, and there's a distribution here. So what I think would be the best form would be to write everything out and then try and combine like terms. So I'm going to rewrite what I have down here, give myself some room, try and simplify this. 7,532 plus 100y squared plus 10 and y squared minus 110. Okay. There's no operation going on this first set of parentheses here, right? I'm just adding them together. And I can see that I'm also adding this over here. So I can just leave that first set of parentheses there. But I'm going to want to distribute this 10 to this second set of parentheses. So 10 times 10y squared will give me 100y squared. 10 times 110 will give me minus, watch my signs here, will be minus 1,000. 1,100. All right, just adding 0 on there. And I can see, right, I have like two types of numbers, you could say, right? Two types of terms. I have a term with a y squared. I have 2 of those. And I just have 2 like straight up constants, just numbers, not attached to any variable. So I can simplify those 2 like terms, and then I can go from there. 2 sets of like terms, let's say that. So if I want to simplify here, once again, this parentheses here is just an addition, right? So I can just rewrite this really all as one. 7,532 plus 100 y squared plus another 100 y squared minus 1,100. Those 100 y squared terms would combine, add, to get 200 y squared, which is already kind of filling the form of this ay squared, right? I have some constant, some value, some coefficient in front of my y squared term and my y squared. And then I need to simplify those other 2, 7,532 minus 1,100, just doing this written out. 6,432, right? That's going to be positive, so plus 6,432. If I see, this fits, right, the perfect form of this ay squared plus b. Right? In this case, a will just be represented by that 200, and b is represented by that value. So a is equal to 200, and b is equal to 6,432. The question originally says, what is the value of a plus b? So I want to add these 2 together. So a plus b is equal to what? That's the question. 200 plus 6,432 is equal to 6,632. That is my answer. I would grid in 6,632 for my answer. All right. So that finishes up section 3. We'll move on to section 4. Not just yet, there's a lot of questions here, 38 questions. This is also the calculator section. We'll jump right now to the slides, these problems. There are a couple topics in here I wanted to touch on. Let's see if I can find them in here. We did a lot of exponents and radical type problems last time, which was good. I'm gonna focus on now, perfect, is our SOHCAHTOA, our trig related problems, right? Our trig functions. Let's see how many we have in here. Yeah, these would be some good problems to do here. And then there's also some volume. Oops. Some volume related problems here at the bottom that I think we'll also take care of before we jump back to section 4 of practice test 7. So let's go back to SOHCAHTOA. This is page 78 of the PDF. Now we're looking on page 79, number 30. Okay, the radius of the base of the right circular cone shown below is 5 inches. And the height of the cone is 7 inches. Solving which of the following equations gives the measure theta, right? This is a Greek letter theta. It's just like a variable that is always geared towards an angle. Theta always represents an angle. If you've ever taken physics in high school, you'll work with theta in physics too. Anyway, solving which of the following equations gives the measure theta of the angle formed by a slant, height of the cone, and the radius. So we're looking for the theta here. Let me just kind of extract this right triangle that we're working with. This is our theta. This is our angle of interest, 7 and 5. What's an equation that we could use that would represent, or that would solve for or include theta here? So let's think about it. And we know that this whole section, right, is titled SOHCAHTOA, right? So let me write out what we have here. So we know sine is equal to opposite over our hypotenuse. Our cosine is equal to our adjacent side over our hypotenuse. And TOA, our tangent, is equal to our opposite side over our adjacent. So given this angle here, this theta in this right triangle that I drew, what trig function do I want to introduce that would enable me to solve for my theta here, but also has the values that I'm given, right? I don't want to work with my hypotenuse here because I don't know what my hypotenuse is, right? I don't want to introduce another variable that I don't know what it is. So I just want to stick to what I do know. So I know this 7, this one leg of my right triangle. That's my opposite side, right? This would be my hypotenuse, right? And this 5 would be my adjacent side. So I want a function that introduces my opposite and my adjacent. Sine and cosine both use hypotenuse, right? So those are not functions I want to use. I clearly want to use tangent here, right? It has my opposite and my adjacent there and there. That's good. So if I represent this as an equation, right, how can I kind of bring theta in here? Tangent of theta of this angle must be equal to my opposite 7 over my adjacent 5 tangent theta is equal to 7 over 5. These were not functions that we wanted to use. And be careful, they give you 5 over 7 as one of the answers. That would be the opposite. That would be flipped. We want 7 over 5. That's answer G there. Okay. That was page 79. We're moving on to page 80 here. Let's see what we got. Okay. A line through the origin and 10, 4 is shown in the standard XY coordinate plane below. The acute angle between the line and the positive x-axis, has measure theta. What is the value of tangent theta? So talking about this angle here as being theta. What is the value of the tangent of that angle? Well, this might look a little intimidating up front. It's like, well, we don't have a triangle here. How can we possibly do that, right? Well, if you think about it, we could introduce a right triangle here 2 ways. I could either draw one here, or I think the more easier way to see it would be here, right? If I drop this line down and make it perpendicular with my x-axis here, this value 10, 4. Let me align it more with that coordinate, with that point. There we go. 10, 4 means that 10, right, is my x value. That's how far I am from the origin along the x-axis, right? This origin is 0, 0. 10, 0 would be this point here. So what is the length of this leg? Just 10. And then we know that 4, right, my y term here in this coordinate is describing the y position. Really, that's just my height, 4. So I've now introduced this right triangle. And they're specifying that they want me to give them tangent theta, right? We're looking for tangent theta. We just worked with tangent in the last problem, right? Tangent requires the opposite over the adjacent, right? So tangent theta here would be my opposite 4 over my adjacent 10. So I don't need to find my hypotenuse, right? This, we usually define the hypotenuse as being C. I don't need it. So tangent theta of this angle is my opposite, 4. This one's my opposite if theta there is in the bottom left. This is my adjacent angle here. Opposite 4 over my adjacent 10. Now that's none of the answers here. Definitely not these, there's no radicals. But the simplified form of 4 over 10 is 2 over 5. And that's fine. You just have to remember that tangent theta is just a relationship. It's just a ratio, right? They're relating this leg to this leg. And it might seem like, well, we're not talking about 2 over 5. We're talking about 4 over 10. It's the same thing. The relationship between 4 over 10 here, 4 over 10 here is this 4 over 10 is what tangent theta is expressing. It's saying this relationship. So 2 over 5 is true. The tangent theta being expressed as 2 over 5 is the same exact thing as it being expressed as 4 over 10. So this is true. D is our answer. We know E. It's kind of a bait answer, right? That would be if we got them backwards, if we put our adjacent over our opposite. So tangent theta is equal to 4 over 10. It's also equal to 2 over 5. Okay. Let's keep moving here. In a right triangle, one angle measures x degrees, where sine of x is equal to 4 over 5. What is cosine of 90 minus x? Seems kind of like a difficult, intimidating problem up front, let's just think about what we're given. They're writing this as sine of x, and x is just representing some angle. They're just using x here really where we might normally use theta. It doesn't matter, theta is just a variable. It's like I said, it's more specifically or most often used geared towards an angle, but x can work too. So we're talking about sine of x, some angle x, and if it's equal to 4/5, they're giving us the lengths of two sides of that triangle. So let's sketch out what we have here. So it doesn't matter. I can call either of these angles, obviously not my 90-degree angle. I can call each of these angles x. I'm going to call this angle x. And they tell me that the sine of angle x is equal to 4/5. Remember, sine is equal to our opposite over our hypotenuse. So if I kind of map this onto this 4/5, right, this means that 4 is my opposite and 5 is my hypotenuse. So 4 is here, 5 is here. Give myself some room. That means 4 is there, 5 is there. Where am I at here? If I want to complete all the sides of my triangle, this stands out to me as a 3, 4, 5 right triangle. Oops. So this is 3 here. But what I really need to do is I need to find out what this angle is here, x. I could do that by taking the inverse sine, also the arc sine, sometimes it's represented, of x, like this. If you have your calculator, but it depends if this was a calculator section or not, I could take the inverse sine of sine x. And then I would also have to do the inverse sine of 4/5 to get x. But if I also think about what this question is asking here, what is cosine of 90 minus this angle x? 90 minus that angle x must be, let's say this 90 minus x, let's say that's equal to y. That angle y is here. It's the other angle, right? We know that the angles of a triangle are 180 degrees. 90 of those degrees are eaten up by this right angle here. So these two other angles must be equal to 90. So this angle that's represented by 90 minus angle x must be this angle y. So what they're really asking for is what cosine y is. So I don't need to actually introduce arc sine. If I just think about this, what is cosine of y? So cosine y, once again, cosine is adjacent over hypotenuse. I always like to think like you think like cooperate or co-worker, whatever. Co means with, right? And so to me, it makes sense to understand cosine as being the relationship that involves an adjacent one. Cosine is adjacent over hypotenuse. So if we're referring to this angle y here, my adjacent is 4 and my hypotenuse is 5. So cosine of y is 4/5. Turns out that's what I originally had, right? So the cosine of this angle y, let me try and highlight these here. The cosine of this angle y is the same thing as the sine of this angle x. They're actually describing the same relationship, just written two different ways. So the answer here is 4/5. If the sine of this angle x was 4/5, this angle here was 4/5, then the cosine of this angle is also 4/5. So that's my answer. 4/5. That's a good problem though. Lots of trig flexibility, let's say. Got to be able to think about trig in a few different ways there. Okay. In the triangle above, the sine of x is 0.6. What is the cosine of y? Well, this is exactly what we just did. This also might jump out to us, the sine of x being 0.6. You know, usually we see sines represented as fractions, because that's an easy way to represent something that is a ratio or a relationship. You don't really see sines represented as decimals, but we could even really make a fraction out of that decimal. Anyway, what they're saying here, right? What is the sine, excuse me, the sine of this angle y? I'm sorry, what is the cosine of that angle y if the sine of this angle is 0.6? So let me assign some variables here. We'll call this A, we'll call this B, and we'll call this C. Just to show this from a different angle. We know it should be a similar way of thinking about this as the last problem. Let me write what the sine of x should represent in terms of A, B, and C. If the sine of x is that angle there in the bottom left, the sine of x should be my opposite, B, over my hypotenuse, C. The cosine of y should be my adjacent over my hypotenuse, so it should be B over C. So sine x and cosine y are once again both describing the same exact relationship, the same ratio between certain lengths of a right triangle. So if sine of x, I'm just trying to formulate this in a more concise way. If sine of x is equal to 0.6, and that's equal to B over C, B over C is also equal to cosine y, so cosine y is also equal to 0.6. Okay. Do a couple more, like I said, then we'll jump back to the last math section there in practice test 7. See if I can maybe pick through. We might be able to get through these. Let's see how far we get. All right, this is page 83, number 35. We have a right triangle here. It says in the right triangle above, sine theta is equal to 2 over 5. If leg AC is equal to the square root of n, what is the value of n? So let's think about what we have here. This angle, theta, is in the bottom left here. And they tell us that sine of theta is equal to 2 over 5. Once again, sine, our relationship sine, gives us the opposite over the hypotenuse. So let me, I'm going to call these sides x, y, and z. Z equaling 10, we have that value. We don't have a value for x, we don't have a value for y. But they tell us that sine of theta is equal to 2 over, sine of theta is equal to 2 over 5. So that's my opposite. That's my opposite over my hypotenuse. This is telling me then my hypotenuse must be 5, right? Well, not necessarily. Once again, like we saw in one of those previous problems, these relationships can solve. It's just a relationship between, or a ratio between two numbers, right? 2/5, if you think about this in terms of more objective decimals, 2/5 as a decimal is 0.4, right? An expanded version of that, right, a non-simplified version of that would be 4 over 10. And 4 over 10 is also 0.4. If I complicated, if I like reverse simplified that even more, if I doubled it again, 8 over 20, it's the same fraction. It's just expanded. It's built a little bit differently, right? So if I think about what this is saying, it's not saying that we need to change our hypotenuse to 10. It's just saying that this relationship 2 over 5 represents the relationship between our opposite side and our hypotenuse of 10. But if my hypotenuse is really 10, not 5, I need to double that 5 to get to my hypotenuse value of 10. So I would also need to double that value of my opposite side, not really being 2, but should really be 4 to represent that side. So that's 4. Y is equal to 4. Let me write it like this. Z is equal to 10. And then that other side there is x. So they tell us if AC is equal to the square root of n, this length, and AC I've defined as x. So if x is equal to the square root of n, what is the value of n? Well, I mean, we could introduce trig here if we wanted to, but we don't have a defined angle. And so we can't, let's say, use cosine theta here, because cosine theta, we don't know what theta is, and we also don't know what x is. So there's no point really in going the trig route here. But we do know 2 of the 3 sides, the lengths of our triangle here, so we could use the Pythagorean theorem. So once again here, they're telling us that AC, we just have to be careful. The side here, AC is equal to the square root of n. So x is equal to the square root of n. Right? So I'm just calling AC x. I think it's a little bit easier to think of that way. My Pythagorean theorem says that normally a squared plus b squared is equal to c squared. In terms of the variables that I'm using, it'll be x squared plus y squared is equal to z squared. So this is where this will come into play, right? I'm not talking about x here. I'm talking about x squared. So if I plug in, if x is the square root of n, the square root of n squared will give me n, which is great because that's ultimately what I'm looking for, the value of n. Plus y squared, I have a value for y, right? That's 4. That's here. I can square that. And then z squared, I have a value for z, 10. I can square that. So once again, the square root of n is n, plus 4 squared is 16. 10 squared is 100. Subtract 16, n is equal to 84. That's my answer. Number 19, triangle PQR has right angle Q. Okay, so let me draw out my triangle. As long as I'm being consistent and calling my right angle Q, it doesn't really matter if I call this one P and this one R, or this one R and this one P. Doesn't really matter. But I'll keep it that way. Angle PQR right there. Okay, triangle PQR has right angle Q. If sine of R, so we're talking about the sine of this angle, the sine of this angle, and I guess we could call this, let's call this angle X. So when they say the sine of R, in our purposes, they're really talking about the sine of X. The sine of X is equal to 4 over 5. Once again, sine tells us opposite over hypotenuse. So opposite over hypotenuse, 4 over 5, means 4 is our opposite over our hypotenuse, 5. Okay, that's helpful. Once again, we hopefully should know that one of our right triangle triples is a 3, 4, 5. So that means that this leg must be 3. We could do the Pythagorean theorem to find that leg out, but if we know that off the top of our head, that's really helpful to know. Anyway, that leg must be 3. The value of the tangent of P. So it is very helpful that we know that value of 3, because taking the tangent of this angle P, and we'll call that I don't like, to me, it seems like P should represent more of sides and corners, not angles. But anyway, angle P, I'm just representing with angle Y. So if I take the tangent of this Y, I'm going to need my opposite over my adjacent, and my opposite involves this 3, this side that I now knew for my Pythagorean triple. So that's great. So 3 is my opposite, 4 is my adjacent. So the tangent of P, we'll keep it that way, really tangent Y, doesn't matter. Tangent P is equal to my opposite over my adjacent, right? So TOA, T-O-A, tangent is opposite over adjacent. Tangent P is equal to my opposite side, 3 over my adjacent, 4. That's it, 3/4. If it was a grid in and I think you can grid in answers, right, as you can bubble in 3, bubble in a line, and bubble in a 4. Or we also know that 3/4 is equal to the decimal 0.75. Those are both true values. Those are both correct. All right, and I think this is, so I'll give you maybe a minute there if you need to pull that back up. The link should still be there in the chat. Mr. Weinkopf sent that there. This is page 46 of that PDF, SAT Practice Test 7. This is the calculator section too, so if you have your calculator handy, good, we can use that here. They also give us a few geometric formulas and relationships here. Always good to have, and obviously good to have, and maybe good to jump back to, especially if you're stuck on a geometry related problem. Maybe just going here and seeing, oh right, this is a special right triangle, for example. Let's say that kind of can refresh you maybe on some relationships that were in that problem that you missed. So pretty straightforward one. Number 1. Question says, what fraction of the dogs are fed only dry food? Well, we should be looking here clearly at this row in the table. Fed only dry food are 2. So it's definitely gonna be 2 over something, but it's important to find, right? So that knocks out a couple, well, it knocks out C, it's definitely not that one. What fraction of the dogs are fed only dry food? Well, fraction of the dogs, they're not saying fraction of the total number of pets. So 41 is not relevant to us. So not that either. And also 7, we're not talking about the fraction of pets that are only fed dry food. So not 7 either. 2 out of 25 would represent the number of dogs that are fed only dry food. So B here is our answer. That makes sense. Yeah, let's move on to this one, number 2. Might try and be a little choosy here about the problems that we do in our last 10 minutes about. Number 2, okay. Which of the following expressions is equivalent to the one above? So we have x squared minus 3, parentheses, minus, in parentheses, negative 3x squared plus 5. So we just really want to combine like terms here. Squared minus 3, I'm just going to write that now without the presence of the parentheses. But I need to be careful. This negative sign here is being distributed here and here. So when that negative sign gets distributed to a negative 3x squared, I actually get a plus 3x squared. When that negative sign gets distributed to a plus 5, I get a minus 5. So I get x squared minus 3 plus 3x squared minus 5. I can combine these two terms. X squared plus 3x squared gives me 4x squared. I can already tell that knocks out 2 answers. Minus 3 minus 5 gives me minus 8. So A is my answer. The combining like terms problem. Good. Okay. Yeah, let's do number 3 here. Good question. It says a certain package requires 3 centimeters of tape to be closed securely. What is the maximum number of packages of this type that can be secured with 6 meters of tape? So one package requires 3 centimeters, 3 cm, right? Just our abbreviation for centimeters. What is the maximum number of packages of this type that can be secured with 6 meters of tape? They tell us that 1 meter is equal to 100 centimeters. So if 1 meter is equal to 100 centimeters, then 6 meters, right? Scaling this up 6 times. I need to scale this up 6 times. 100 centimeters times 6 gives me 600 centimeters. So the question is, if I'm given 600 centimeters of tape and one package requires 300 centimeters, how many packages can I take care of? Well, if 600 centimeters is like my store, right? It's like my stock amount of tape. Each package requires 3 centimeters. 600 divided by 3 gives me 200, so I can do 200 packages. Answer is C. Yeah, let's look at number 4 here. Got about 10 minutes left on the home stretch here. Number 4, a market researcher selected 200 people at random from a group of people who indicated that they liked a certain book. The 200 people were shown a movie based on the book and then asked whether they liked or disliked the movie. Of those surveyed, 95% said they disliked the movie. Which of the following inferences can appropriately be drawn from the survey result? So maybe read over that one more time, because it has numbers obviously involved in it, but it's more of a qualitative type of question. They're asking us to, which of these things, given the data and given these percentages that we know, is true. We want to make sure that we're not overstepping our bounds and we're not drawing inferences that we can't really back up. So we have 200 people at random from a group of people who like this book. They were shown a movie based on the book and then asked whether they liked or disliked. So only 2 choices, right? Either liked the either liked the movie or disliked the movie. But all of the people indicated that they liked the book, right? Everybody likes the book. It's just a matter of whether or not you like the movie. Of those surveyed, 95% said they disliked the movie. Which of the following inferences can appropriately be drawn from the survey result? A says at least 95% of the people who go see movies will dislike this movie. No, that's not right, because we're not just talking about generally people who go see movies. No, we're talking about people who like this book, right? That's where we're pulling these people from. So no, that's not true. B, at least 95% of people who read books will dislike this movie. Once again, no, right? We just didn't take random people who read books. We took a group of people who indicated that they liked a specific book. So no, that's also not true. C, most people who dislike this book will like this movie. No, that's definitely not right. We took people who liked, I've really written over this here. We took people who liked this book, and from people who liked this book, we found out that 95% of people disliked that movie. We can't flip it and say, oh, well, if you like the book, you're going to dislike this movie. We can't do that. This doesn't make sense. People who dislike this book, we didn't survey people who dislike this book. So no, not possible. But, so this looks like D must be our answer. Most people who like this book will dislike this movie. That's true, because we surveyed people who like this book, indicate that they like this book, and we found out that 95%, right? That's definitely most people. Most people would be 50, 51%, right? A simple majority. Dislike this movie. Answer is D. So with a question like that, right, you just have to make sure you're not overstepping your bounds, right? You're not taking what you're given and trying to make too much out of it. Okay, that was number 4. This is a good one. Number 5, kind of a conditional type of question to give you three statements, or really in this case, 3 answers. Which ones are true? Number 5. Which of the following ordered pairs, giving us 3 ordered pairs here, satisfies the inequality 5x minus 3y is less than 4? So to satisfy the inequality, it means it needs to be true. If we plug in these values from these coordinates, 1, 1, 2, 5, 3, 2, if we plug those in for the x and y values, is this 5x minus 3y with those numbers plugged in there, is that less than 4? Well, if it is, yes, it satisfies 4, and that's true. If it doesn't satisfy it, meaning if we get like 7 is less than 4, that's not true. 7 is not less than 4, does not satisfy the inequality, then no, that ordered pair would not work. So you can just plug these in. So let's try number 1 here first, or letter 1 here. Plug in these values. 5 times 1, if I plug in my 1 in from my coordinate, minus 3 times 1, is that less than 4? Let's see if that's true, right? This part, this less than 4, that's really what we're testing to see if it satisfies it. 5 times 1 is 5. 3 times 1 is 3. So 5 minus 3 is 2. Yes, 2 is less than 4. That checks. That makes sense. So, then it can't be B, right? Not possible. All right. Let me do the next one. Number 2, 2 and 5. My point is 2 comma 5. Plug this in. This is going to be 5 times 2, my x value, minus 3 times y. My y value here is 5. Is that less than 4? 5 times 2 is 10, minus 3 times 5 is 15. Is 10 minus 15 less than 4? 10 minus 15 is negative 5. Yes, negative 5 is definitely less than 4. So 2 is correct. We can see then it must be C, and also obviously can't be A. So this means that D should be wrong. D involves number 3. Let's just be sure that D is incorrect, that it does not satisfy the inequality. So I have 3 comma 2 by plugging in 5, 3 for my x, minus 3 times my y value of 2. Is that less than 4? 5 times 3 is 15, minus 3 times 2 is 6, less than 4. 15 minus 6 is 9. No, 9 is not less than 4. That's not true. So this one does not work. So 1 and 2 do work. Answer here is C.
Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.